Let's talk a little bit about the adhesive. How to go about selecting an adhesive and what makes a good strain gauge adhesive. As opposed to adhesives that you might use at home. Or you guys have hot glue guns here? You know what a hot glue gun is? It's got a little piece of glue about the size of my finger that goes in and it gets hot. Use it for like making Christmas ornaments and, you know, all sorts of like arts and crafts kind of stuff. Well, you can't use hot glue guns to bond down strain gauges. They would stay down, but it wouldn't transfer strain. So, what are the ideal characteristics of a strain gauge adhesive? The first is that we want to form a strong permanent bond with any type of specimen and any type of gauge backing. Second is that it would be easy for us to use it. Third is that you'd have enough pot life and handling time to apply a large number of gauges. Fourth, and this is the one that's most important, forms a thin void-free glue line. And that's one of the things we look for, is to make sure there's no voids underneath the gauge. That can transmit strain without creep effects. Who knows what creep is? Creep. What does that mean? Creep is when you apply a load to the structure and you keep that load constant. Does it change? Composites and plastics, they will change. They're very time dependent. So you put a load on it, let's say it's cantilevered out, and you don't change the weight, but yet that thing moves a little bit more and a little bit more. Not all materials have good creep properties. The aluminum that we're going to use to put a gauge on is 2024 T4 aluminum, and it's got very good creep properties. Plastics are notorious for having poor creep properties. Now, one of the things you do, though, in evaluating the strain gauge installation is you look at creep. And the important part of this is which direction it goes. Positive creep is normally in the material. That's the thing that you're testing. That's the piece of metal or plastic or composite that you're putting the gauge on. And there's nothing you can really do about that other than pick something else, because it's going to have whatever its creep properties are. But the installed strain gauge can also exhibit creep. And if they're not bonded well, they'll show negative creep. So imagine you hold it, you apply a weight to it, and now all of a sudden you're creating a tensile strain along the surface, and now you start to see the readings change and they go negative. It starts relaxing. That relaxation is normally creep that could be in the glue line of the gauge. So that's one of the things we evaluate. When we put a gauge on, we try to look for how does it behave in terms of creep. If you use an adhesive system that's maybe not cured properly, it'll show negative creep. If you use that hot glue gun that I talked about, for sure it's going to show negative creep effects. We don't want that. And then the last one here is operates at deep cryogenic temperatures up to the highest temperature usable. These are kind of the characteristics we're looking for. And the adhesives, you can kind of group them into three categories. First category is cyanoacrylates. That's what we're going to use this morning. That's what is in this box. We call it M-Bond 200. Very quick, very easy. But it has a couple of drawbacks. Number one is you got to keep it away from heat and humidity. Doesn't like either one of them. And by heat, it needs to be less than about 75, 80 degrees C. It needs to be less than that. Humidity, if it's very humid outside, that can be a problem. Sometimes it doesn't want to react properly. In addition, it gets brittle over time. It gets old. So over time, if you wanted it to last, let's say you knew that your installed gauge, you wanted it to last longer than a year, you probably don't want to pick that one. You want to pick something else. In general, we say 1 year. Anything longer than a year, you want to go to an epoxy adhesive, epoxies. And that's the next category. Epoxies consist typically of two materials. You got a curing agent and a resin. We mix it up. And it has a certain amount of time for us to be able to use it. One of the reasons for selecting an epoxy is that they're stable for long periods of time. So let's say you're going to put a strain gauge on a bridge and you want it to last for a few years. This would be the type of adhesive system to choose. Also, they have a tendency to be a little bit thicker. So that added viscosity is actually better if you're on a rougher surface, like a composite. It's got a little texture to it. These are good for kind of filling that surface and smoothing it out. So a little higher viscosity, much more long-term than what a cyanoacrylate would be. Another nice thing about them that we don't talk about so much is also these can be a 100% solids. So there's no solvent in it. And sometimes with plastics and composites, solvents can react with them. So you've got to be careful of that. So if you're testing plastics and composites, you may want to select one of these because there's no solvent in it. No worry with reaction. And then the last one is solvent thin epoxies. And these are some of the highest performance adhesive systems we've got. They're going to create very thin glue lines, very long term. The scales at the airport that said Mettler Toledo on it, that weighed my luggage, those scales were installed using, the strain gauges inside the scales were installed using solvent thin epoxies. They're much better for production type environments, high volume environments, but they have a disadvantage to them. They're not very reactive. So what does that mean? It means that you have to elevate the temperature to cure them. You got to put pressure on it, and you got to get them hot. You leave them room temperature like this and they won't cure. So what manufacturers do a lot of times is they'll build a big batch of transducers and they'll shove them all in the oven at the same time and cure them. Oftentimes you need about 300, 350 Fahrenheit or about 175 C to get these to cure. And then these are the ones that we offer, and these are the corresponding product numbers. We've got the Inbond 200 that we'll use. We've got 8010, 8015, both two-part epoxy systems. We got Inbond 600 and the Inbond 610 that are two-part epoxy phenolic systems.